If anyone has any questions, again, general questions, just type them in the Q&A and I'll hand it over to Taylor.
All right, thank you so much, Crystal. Hi, everybody. Thank you for joining me today. As Crystal said, my name is Taylor Carter. I am the Regional Architectural Manager with the Southeast region with Marinaware. And today we're going to teach you guys about interior non-load bearing partitions, specifically using steel studs. So we're going to go ahead and get started. As Crystal just said, you will be receiving 1 credit for this course. This is an hour-long course. So she will be sending all of your certificates to you. And if you want to stick around at the end of the presentation, you will be able to get my contact information as well. If you have any further questions that I'm unable to answer, I will be providing my email as well as my phone number and so on. So let's go ahead and hop into the course. So a course description. Today we're going to go over the proper framing of interior partitions. It is important to the structural integrity of the interior living space. In this 1-hour introductory course on cold form steel framing for interior non-load bearing partitions, design professionals will gain knowledge about the integration and documentation of cold form steel building systems into a project. Here's our learning objectives. We want to understand the interior partition framing, describe various types of metal studs, understand the installation methods, and explain code compliance of common materials that are used in the marketplace today. The lesson agenda, we have number 1, going over our LEED and how we can achieve our LEED certifications, the specification and how you're able to hold your specification, the basic design guidelines with the catalog table. So this will kind of go over the different types of minimums that you need to reach to abide by code with your project. We'll go over the methods of installation and the different uses of the different types of studs. I will give you guys some resources that you can contact if you want to get more information outside of this presentation. We're also going to go over code compliance and the different types of ways that you can achieve meeting the minimums. And then at the end, we'll answer any questions. So like Crystal said in the Q&A, if you have any questions, please put them in there. I will go ahead and let you guys know now that I am 8 months into the steel industry. If there's something I'm not able to answer, I will be sure to make sure you get my email so that you can email me separately. Or if I have your email, I will email you with the answer to your question. So let's go ahead and jump into it. What is cold form steel? So cold form steel is a recycled material that comes from a mill, comes from a mill in coils that are approximately 40,000 pounds and 48 inches in width. We can take the coils and we actually slit the coil to slit widths depending on the size and the type of section, and then form them into a shape. So the most common shape that you see is actually going to be the C shape that you see on your right. We then barcode the coils for our inventory so that we can track them and find out where they came from. We also test the thickness before we begin forming shapes to ensure that they are compliant with the code. So with today's technology, we can make just about any shape that you may need out of your steel, cold form steel. When you look right here, these are some of the most common shapes that you're going to see. So we have like your C shape, your T track, your U channel, your L angle, as well as your furring channel, along with all the different types of sizes that they come with. Now, typically, when you have a stud or whatever shape that you're going with, you're going to have a product identification number. So you can see here is this sample. We start with the 600. So that's going to be your member width. All member depths are taken in 1 in 100 inches. So for all T sections, the member width is in the inside to the inside dimension. So then we also have our flange width, which is that 162 number. Then we also have our style, which is also classified by this S. So this could be multiple different letters. So S for stud, T for track, U for U channels, and F for furring. And then we also have our material thickness. So material thickness is the minimum base steel thickness in mills. It is 95% of the design base steel thickness. Then we get into LEED. So how can we establish getting our LEED accreditation? Steel is the highest recycled product in the United States. Because of this, steel is a LEED certified product and it can add up to 6 points on any LEED project. You must still consider other building products in lead jobs to reach these points, but steel can definitely help you achieve your goal. Steel products can be recycled repeatedly without losing any of its structural properties. And this in steel, we actually used to make cold form steel products. It's made from almost 100% recycled material. So waste accounting for a small portion. If you have a lead job that you are looking for credit on, manufacturers will supply a letter for each specific project so that you can achieve your points. So kind of a cool note to kind of put in there, just kind of give you guys an idea. So steel studs is actually one of the highest, most recycled products out there. And we fall just behind number one being the automotive industry and number two being your appliances. Just to give you an idea, I had a coworker that was actually in the Navy. And he actually was telling me how the USS New York, which is actually a Navy boat, a Navy ship, was actually used 100%, the whole entire bow, from recycled material after 9/11 when the towers fell. So a lot of the steel that was actually all mangled up in that project was actually recycled again and then used for the greater good of putting it into a Navy ship. So it's just something really cool to keep in mind that you can recycle over and over and over again with steel. Here's some of the resources. There's a few different websites listed that you can go to if you need more information on steel's recycled content. So a few of them is the U.S. Green Building Council at usgbc.org. You can also visit the American Iron and Steel Institute at recycle-steel.org. You can also ask for your environmental product declaration or your APD. There's two types available from the cold form steel manufacturers. Some companies have third-party verified product-specific type 3, and there was one current industry generic EPD valid for 13 different manufacturers. So you want to look for the HPD as well, which is the Health Product Declaration. So to get into what a non-structural steel framing member is, you have your AISI, which is the American Iron and Steel Institute. These standards are free at the AISIstandards.com. And AISI S220 is the product standard reference in the IBC 2015 edition, and later for the cold form steel drywall framing. So by definition, a member in a steel framed wall system, which is limited to a lateral load of not more than 10 pounds per square foot, a superimposed vertical load, and exclusive of sheathing materials of 100 pounds. This is commonly referred to out in the field as a drywall stud. It's used for interior framing, so non-load bearing, and it's going to meet the requirements of the code that we just discussed. For material specifications, you want to hit a minimum G40 coating or equivalent, a minimum 33 KSI yield strength or tensile strength. Your steel sheet needs to meet the ASTM A1003. And individual members shall have the legible code, stencil or embossment at a max distance of 96 inches on center. So basically, if we go back to that slide where we were talking about the manufacturing code, on every single metal, you're going to actually see this implemented 96 on center on everything. If they are not doing that, they are actually breaking code. So I'm not going to go over this, this table that you see here. Basically, what we're showing is that manufacturers need to always be listing these dimension, all these different sizes, because they're basically saying that they're meeting the minimum. So this is just basically showing the different types of lengths and such and how you're meeting the minimum by doing so. So with wall studs, the way that we actually measure the wall studs is we have our web, which is typically going to be in 1 5/8 inch, 2.5, 3 5/8, 4 inch, and a 6 inch. We also have a minimum flange, which is 1 1/4. Your gauge 20 and 25. So 90% of the industry promotes alternative EQ studs, which we're going to get into a little later on in the presentation. You also have your return lip minimum, which is 3 16 inch. And then you have your track. So your minimum leg is about 1 inch, but most of the manufacturers require 1 1/4 minimum for sheathing attachment. Let's talk about your tensile strengths. So this is going to be kind of comparing your conventional stud versus your non-conventional, or how you could say your structural versus non-structural. So as you can see here with your non-structural, we are actually able, I'm sorry, with your structural, we're actually able to go from 33 up to 118 thickness, non-structural 18 to 30. Your design thickness, the only difference is that you're actually galvanizing that product. So with your minimum base thickness, you're looking at just the metal itself. Your design thickness will be included with that galvanization, whatever it is that you're dipping that steel into. So what is an EQ drywall stud? So if you're thinking about like value engineering, I always tell people you should be getting the same value with a cheaper price. You should not be having to, take away from that tensile strength. So an EQ stud is just that. You're getting a thinner product with a higher or the same tensile strength. So these are non-load bearing proprietary shaped studs. They incorporate technology to increase the strength with a thinner material, a stronger steel. It's reinforced with an engineered shape. So some of those shapes inside the stud can actually add to the structural integrity. The thickness is only one part of the equation when it comes to metal framing performance. There's multiple manufacturers, 30 different manufacturers offering 18 different proprietary EQ studs. And they've been available in the market since 2005. The studs are considered equal to or conventional if they meet the following criteria. The nominal moment equal to or greater than the nominal moment of similar standard product. The stud must pass a screw penetration test. The screw shear and pull-out values must be greater than the values for a similar standard product, and you must be verified through a third-party testing. When we take a look at this, we're looking at a conventional stud versus an EQ stud. So you're not going to see an EQ stud go into your structural, but you will see them for your non-structural. So let's do a little comparison real quick. So we have a 25 gauge at 18 mils, so that's the thickness, and you're getting a 33 KSI. If we take that same 25 gauge EQ side, minimize the product to a 15 mil, you're actually getting a 50 KSI. So then let's do it again. We have a 20 gauge drywall side at 30 mils, getting 33 KSI, and then another 20 gauge EQ at 19 to 22 mils, getting you a 57 to 70 KSI. What we're showing here is when you're doing your installation, to also add to the integrity of your stud in your assembly, you want to make sure that everything is aligned properly. So as you can see in this little detail here, our studs are facing the same way, perpendicular, equally spaced. There's no issues with putting the screws in the proper way. Your U-shape is used as a closure for the stud assemblies at the floor and ceiling. The web depth is compatible with those of the studs. And when studs are placed in both the top and bottom track, they are held by friction. So we're basically just saying you want to align everything. Just like you see in this picture, all of your cutouts are aligned equally. There's none that are flipped upside down. You want your track to be aligned on the floor and the ceiling. You want to securely anchor the track approximately 2 inches from the runner ends and not more than 24 inches on center. And then the stud on center spacing, not more than 1/8 plus or minus. So once again, the stud should sit between the top and the bottom of the track, and the flanges facing the same exact direction. You want to allow a 1/4 inch gap between the stud and the track unless designed by a registered design professional. So the reason that we actually leave that 1/4 inch gap above your stud where it's aligning with the track is for your deflection. Otherwise, you're not going to have the space for the movement, and then you're going to have a failure. At that point, you're going to have deflection issues, too much load, it's going to bend, snap, whatever it may be. You also want to attach the flange of the stud to the flange of the track with screws, unless fire rated or other specific assembly does not allow for it, which is also going to be something that the engineer would make a decision on. Now we're going to talk about your bracing, because there's a lot of different things that go into times. So you have your composite limiting height. So this is basically a vertical application of 5/8 inch type X gypsum board. The board is type X gypsum board screw spacing, usually using a number 6 screw on 12-inch centers, or as described by the manufacturer's literature. So your fire rated partition assemblies override this requirement sometimes. and a sound assembly screw spacing may be different as well. So for deflection conditions, you want to check with your manufacturer. So basically what we're saying here is the only time that you're going to use something different is if you do have a fire rated or sound rated assembly, and typically the engineer is going to come in on that. Then we also have our non-composite fully braced walls. To use a non-composite fully braced walls, you want to look at your LU, which is going to be your critical unbraced length. So these are the different reasons that you would use an assembly like this, is if you're sheathed on both sides, but the assembly is not exactly as tested for composite tables, such as gypsum orientation, the type that's used, the thickness, as well as the fastener spacing. You also want to check in if the walls with the resilient channel with spacing is less than the LU. The partially sheathed and unsheathed portion is less than LU. Unsheathed, but lateral bracing spacing is less than LU, or partially sheathed, but the spacing between lateral bracing is less than LU. Non-composite, you want to have the 48 inches on center brace, and you would use the 48 on center brace when the gypsum board is only on one side, the walls with the resilient channel space is greater than LU, or this application is going to be used for a furring wall. Now, when we're talking about the different types of bracing, there's a lot of different applications you can do. This is one of them. This is using a back strap, is what we like to call this, or a flat strap. So basically what this is just a thin, kind of wide steel plate, essentially. And they're actually using this, and with the proper screwing, they are screwing it back behind those studs. So by doing that, you're actually adding a support system there. Another way that we do this is the detail that you see here. So they're basically using another piece of stud. So they take a standard piece of stud, they then flip it to the horizontal, and they actually cut out the exact width of that stud into the studs that are actually holding up the wall. And it's flush with the back of the stud by using a screw attachment. So that's another way that they do that. Here we're seeing your typical, this is going to be a cold roll channel. So this is another, probably one of the more common ways that we see it, is where they're actually just taking that bracing, putting it through your cutouts, and then by using clips, they are attaching it with a screw. The center line bridging is not very effective for horizontal resistance for studs greater than 8 inches in depth. So anytime that you're going to be doing like a blocking system, or if you need to attach, something that's going to have a load, whether it be like a handicap bar, a TV, whatever it is, that's something that you want to make sure that you run by the engineer to make sure that it is able to handle that load. Something else that we need to take into consideration is our ceiling spans. So I'm going to show you two examples because this is going to kind of give you an idea, of a different type of bracing, such as a mid span. So as you can see here, we have a 9 foot by 1 inch, and we're able to accomplish this with the products used without incorporating a mid span. So this would be considered an unsupported application. But then when we go to a 12 foot by 4 inch, as you can see, we've now had to incorporate a mid span so that we don't have to worry about that stud buckling and having a failure. So this is when you're using a mid span bracing system. Now, I know I have a bunch of architects on the call, so I'm going to go ahead. I'm going to let you guys look at this. I'm going to go ahead and warn you ahead of time that I did not make this presentation. So some of these details might be old technology. You might see something a little funky, but the whole gist of it is that we're showing the different ways that you can incorporate these studs and the different attachments. So here we have an intersection detail. So I'm going to kind of just go through these and let you guys take a look at them. As I said, if you have any questions, please go to the Q&A and put the questions in the Q&A, and you can actually let me know what slide you're asking about, and I can go back and answer them at the end of the presentation. But here, like I said, we have an intersection detail. Here we have your corner detail. This is how the studs are lining up together. And we have a partition corner detail number 2. Again, this is just going to show you your screw spacing, how the drywall is actually being incorporated. This is a block and strap. So when we are talking about, if we're going to be attaching something to the wall with a load, Typically, you do want to get your engineer involved on situations like this, but typically a block and strap system is what you're going to use when you're incorporating those types of items. Here you have all your different windowsills, your windowsill applications, door jambs. Here we're just once again showing your track along with your cold roll channel that's going through your cutouts. This is an application with a slotted track. So what's important about these slotted tracks is how you see the slots on the side. You're able to screw into those and they're able to freely move up and down with the proper spacing to allow for your deflection. Here we're incorporating a kicker. So basically when you're stud, you hit your limiting height, but it's not going all the way to the roof deck. When you need to make an attachment to the roof deck, you're able to incorporate what we call a kicker, which is just another metal piece stud that you're actually using at that diagonal to make a connection. So when we're talking about our drywall accessories, such as like your furring channels and your clips, once again, these are all universal to all manufacturers. You're basically using these tables that you see here. These are going to show you your different minimums with your sizes based on your PSFs and your load. You have your Eliver 240 or Eliver 360. Typically, you're going to use an Eliver 360 when you're dealing, for instance, if you're in New York and you have a hotel that has big doors in the front. From that air, you might want to go a little higher when you can get away with something less. If you're doing something, if you're using an elevator shaft, you might want to use something bigger. So these are just kind of showing the different minimums. Now we also have drywall accessories such as resilient channels. So typically you're going to use these as furring over wood or steel framed walls and ceilings. They reduce contact with supporting members and offers an economical means for reducing sound transmission. And they need to be installed correctly in order to work. So typically what we see out on job sites is installers want to actually, I don't know why, for some reason they like to install this upside down. So the proper way to actually install it is the picture that you're seeing here right underneath the bullet points. Because what's going to end up happening is when you put that gypsum on, you're putting weight onto the application. It's going to cause it to droop. Whereas if you did it the other way, once it started to do that, you're now breaking that airspace and making contact, which is allowing for that sound transmission. So that's really important. You just want to make sure that your installer does know that they're installing it the proper way, upwards instead of down. Here we have the different steel fasteners or screws. The most common one you're going to see is actually going to be your bugle head or pan head, but you can actually see any of these on the job site. Your bugle head is designed for drywall applications, counter sinks neatly without crushing the gypsum core. Then you have your trim head, which is designed to recess into trim and work with minimum visibility. It needs a number 1 bit tip. Your wafer head, which provides bearing surface necessary to fasten plywood or sheathing materials to metal. Your hex washer head, which is a washer face that provides a bearing surface for the drive socket. You have your pan head, which provides a neat finished appearance for general applications. And then you have your flat head, designed to countersink and seat flush in the wood without causing splitting. You also want to keep in mind that self-piercing screws only on a 30 mil and thinner. With a 33 mil and heavier, you can use a self-drill type S12. And when we're looking at, once again, more tables, this is basically just showing you the gauge and the type of screw that you would want to use for those applications. So you just want to make sure that you're verifying with your manufacturers and your installers that the right screws are being used, because once again, they can pull out from the wall. They can strip, which would be an awful thing to happen as well on your project. So these are just some of the examples that you would be using. Now, currently, there are 3 steel stud manufacturer associations. The membership is optional and not required, and about 50% of the cold form steel manufacturers are members of one of these associations. So take note of these. We have our Steel Stud Manufacturers Association, or SSMA, your Steel Framing Industry Association, which is SFIA, and your Supreme Steel Framing System Association, which is SSFSA. So with code compliance, it's important to check with the individual associations to see which manufacturers are listed as certified code compliant. For independent manufacturers, you use their code evaluation reports, or their EPAs. Membership in association does not equate to code compliance certification. So just because a manufacturer is a part of these associations does not mean that they are actually being code compliant. You want to check for your ICCES or the IAPMO or Intertech for code evaluation reports for framing members. So when you're dealing with corrosion, that's something that tends to be a something people worry about. So most contract documents specify that hot dipped galvanized coating or an alternative coating listed in Table 1 of the ASTM 1003. The IBC, through the reference steel standards, allows for other types of coatings, or what we would consider an EQ coating. So steel screw studs are to be 3 5/8 inches, or as indicated on the drawings. The 20 gauge hot dipped galvanized spaced 16 inches on center, where required for utility lines and or wires. Stud webs shall have preformed holes or knockouts not larger than 3 square inches, and the stud shall be intended for use in the screw stud partition construction framing. So basically what we're talking about here is when you're dealing with your coatings. So drywall studs are required to be a G40 or equivalent per the AISI S220. So G40 means 0.4 ounces of zinc per square foot. And it has approved alternative metallic coatings that can be found in the ASTM A1003 Table 1. So if it is not galvanized, it cannot be indicated as a G40, G60, or G90. Some of these coatings are referred to as a G40 EQ, which we're about to get into. These coatings can then be offered as an equivalent to G40. The G40 EQ coatings are applied by the cold form steel manufacturer, and then they actually go through a salt spray tested against the G40 for performance. Typically, a G40 lasts 120 to 144 hours in a salt spray test environment, and any G40 EQ sample needs to exceed that. So just like our EQ stud, if you're going to have an equivalent to your original zinc, it has to actually exceed the minimum that a regular G40 actually passes with. So if it's galvanized, it's labeled as a G40. If it is galvanneal, galvalume, galfan, or aluminized coating, it has to be labeled as such. So you have your galvanneal label A40, your galfan GF30, your galvalume AZ50, or aluminized T1 or T2. G40 equivalent coatings are labeled as G4 EQ. So when we're looking at this, we can go into our track where we have, our web where we have our labeling. So your stud and track that is not individually labeled fails to meet the criteria mandated, which means they are not meeting code if they do not have this imprinted every 96 inches. Any stud and track not labeled is not compliant. So each individual stud and track must be labeled with the name, the initials or logo of the manufacturer per the AISI standards. If it is not a G40, then the coating type must be shown on each stud and track. So basically what they're saying here is if you do not see a G40 on the stud, you can go ahead and assume that it is galvanized. Now, if it is anything else that is actually an EQ to your original zinc, that's when you're actually going to see that on the stud. So if we're using like galvanneal, for instance, you would see the manufacturer along with your sizing of your stud, your tensile strength, and then there would actually be an added label to the end of that showing whatever they use as an EQ coating. So the ASI S220, an example of the label for drywall studs and tracks would be like below. So like I said, you're seeing the manufacturer, minimum thickness, yield strength, And then I'm not sure why they don't show you the G40, but you would be adding, I'm sorry, you would not be adding a G40, you'd be adding whatever the EQ is to the end of that stud. Something you also want to keep in consideration is, I know you guys see what architects like to call it the dimples on the side of the stud. So a lot of your standard studs are going to have dimpling. The main reason for that technology was for the screw pull out. So essentially what was happening is, way back in the day, they were putting the screws inside the studs, and they were actually, once they were putting the gypsum on, it was ripping out of the stud. So that actually helps with the integrity of putting that screw into the stud. That's what that dimpling is for. Do we have any questions? I want to hop into our questionnaire real quick and just see if there was anything in there. Oh, give me 1 second, guys. My computer does not want to work with me. Okay, it doesn't look like I have any questions in the questionnaire. Was there anybody that had any questions that they wanted to ask? You could also put that in the chat. Okay, it looks like Danielle Clegg. So we have, can you discuss the benefits of a G60 coating versus a G40 coating? Yes. So basically, you're just actually stepping up on the thickness of that coating. A G40 is typically used, that's basically like your basic. You typically will not see yourself go into a G60 or a G90 coating unless you're, for instance, if you're building something in Florida where you're on the coast, when you really just want that extra protection from the salt spray. So that's initially when you're going to be doing things like that. Otherwise, or if you're doing like a government job, I know a lot of government jobs like to use a G90 coating. It's really just an extra protection. But ultimately, your whole goal is to, with all your other building envelope that you're implementing, stopping that moisture from ever hitting the stud to begin with. So that's kind of where we're at is, we want to stop it from ever getting there, but as a very last defense mechanism, if that moisture does hit that stud, that's what your coating is there for. Okay, we have Javier. Does it affect the STC rating on the wall assemblies? Javier, I'm a little confused what you're asking, to be honest with you, as far as the STC rating on the wall assemblies. Are you asking if by adding the coating, if we're getting a higher STC? If you could just elaborate a little bit more in the Q&A, I can answer that for you. While we're answering questions, guys, I'm going to go ahead and scroll over here just so you have it. So this is my contact information. If there is a question that is not answered in the Q&A, you are more than happy to email me here and I can answer that question, as well as take my phone number because I am your Florida rep. It looks like, Beatrice, we have another question. When framing a fire-rated corner where one wall is rated and surrounded by a gyp board, why did they hold back the other stud 2 inches versus placing it right next to the gyp board? Let me see what, I'm gonna have to see what slide you're talking about. When framing a fire rated corner, where one wall is rated. I'd have to, Beatrice, I'd have to go back to whatever slide you're looking at. Let me see if I can, I think it was the second slide. Let me take a look. Give me 1 second. I love doing the Q&A at the end because it's just really great for all of our learning purposes. So slide number 2. Oh, slide number 2. Oh, you're talking about the details. Give me 1 second. 1, 2. Okay, let's see here. We have a joint reinforcement. Size and gauge required, gypsum wall. Beatrice, can you go ahead and confirm, is this the slide that you were looking at? Second slide, and the plan details, not this one. Okay. Because I'm not seeing the fire rating. Was it this one here? Yes, this one. Okay, let's go back to the question. When framing a fire rated corner where one wall is rated and surrounded by gyp board, why did they hold back the other stud 2 inches versus placing it right next to the gyp board? Bear with me, I'm just taking a look. That is a fantastic question. I unfortunately do not have the answer, and I'm not going to give you a wrong one. I actually never noticed that, and I tend to notice things because you guys are the architects. So typically, these types of things get pointed out to me, and it's a great question for me to ask my engineering team. So if you did put your email in, I would love to find out about that because that is interesting, and I would love to know myself. I apologize. I don't have an answer right off the top of my head for this one. I'm not exactly sure, and I'd rather not give you the wrong answer. So were there any other questions that anybody had for us? We have the Q&A open, or if you wanted to put it in the chat box, I can check that too.
There are some in the Q&A.
Perfect. Here we go. Okay, so we have stud limitation heights. Can you explain more on that? Yes. So typically when you have a stud, you have limiting heights that you can go unbraced without having a failure. So let's just say, for instance, and I'm just throwing a random number out there. Let's say that you're going up 28 feet, which there are studs out there that have a limiting height of 28 feet unbraced. Basically, what we're saying here is sometimes you have to have bracing, otherwise you have a limited height unbraced. And those limiting heights are as high as you can go without having a failure or without that stud starting to twist or essentially TP and snap. So that's just basically what we mean by limiting heights. You can either go up a certain height unbraced or you can go up a height where you require bracing. We have another question. Does an EQ stud versus conventional stud reduce STC ratings on wall assemblies? No, they do not. So essentially, you should be getting the same performance, but also you want to check with your STC assemblies that were being tested just to make sure. So you want to compare the different values of your studs based on the assemblies. They should have, for EQ studs, whatever assemblies, unless you're doing some oddball project, for the most part, there's all tested assemblies for an EQ stud are going to be the same tested assemblies for a standard conventional stud. And then we have another question here. How are field cut ends of galvanized studs treated? Field cut ends. I need a little more elaboration on that. What exactly do you mean by field cut ends of galvanized studs? I'll give you guys a minute to. Eduardo, if you're still on the call, would you like to kind of elaborate on that so I can give you an answer? I'm not exactly sure. What do you mean by field cut ends? I will go ahead and say this. If what you are saying is when they actually cut them on the fields, that is another great question. I have never had that question before. I can definitely reach out and find out what they do about that because essentially you do have the metal that is not galvanized. So let me get back to you on that one. I'll see if I have your email. If not, you can email me from the email that was provided. Okay, so yes, when a stud is cut on the job site to fit. Yeah, I'll have to double check on that. Like I said, when you cut the end of it, obviously that the inside, well, not the inside, I guess the stud is now exposed. So I'm not exactly sure what they do for that. I will write that down and definitely get you an answer for that because that's actually something good for all of us to know. Okay, were there any other questions before we end the presentation? Nope, I don't see any more. Crystal, are you seeing any more on your side? I think we're all.
I am not, but we still have 20 minutes until 1 p.m. So I'm not sure if you could, so just to make sure everyone gets credit,
Yeah.
not sure if you can elaborate on some of the slides.
Yes, I can definitely do that. Yeah, this is
Okay.
one of our shorter presentations. So let me go back actually for some of the questions that they had. Yeah, I feel like this is probably like the shortest presentation that we have. And usually they have like stories and stuff for me to tell you guys, but with me being brand new, it's been a little difficult to do that. Okay, so I do want to kind of elaborate on this with the manufacturers. So like I said, you are getting these coils, they're coming by train. These coils weigh 40,000 pounds each. So when they were talking about how they actually take samples of that stud, the reason they do that is for the most part, we want to prepare that there's not any issues with the galvanization, that there's no issue on, the stud itself, any type of failure where we have to then, make a claim and come investigate. But the reason they do that is because they're actually able to keep a piece and they can actually tell you where it came from, when it landed at the manufacturing facility. They're able to backtrack and actually get more information on the individual stud coil that the stud came from. So that's something really neat to keep in mind too. Also, every single manufacturer, something that's universal to manufacturers is we do have color coding that is actually universal to every manufacturer out there. So if you're ever walking a steel yard or if you're on a job site and you're trying to find out information about a specific stud or find out what type of stud it is, you can typically go on there and you'll see where they've actually used spray paint of a color, whether it be pink, red, white, you name it. And that's universal for all the manufacturers. So you can just by looking at a stud, see the color and know what type of stud that is. So there's a lot of manufacturers that actually offer the nomenclature cards. On those nomenclature cards, because engineers and architects like to speak in kind of a different language. A lot of engineers typically go by gauge, where I see a lot of architects are going by millage. So it's very important to get your hands on one of these cards if you're not familiar with this, so that when you're ever having an issue on a job site, if the architect has to go out there and investigate with the manufacturer, with the GC, you have this card that's able to tell you that. Also, it can be confusing when you're doing like a size and gauge evaluation. If you're trying to find out, okay, what type of stud should I specify for what I'm dealing with? It's really good to have that size and gauge evaluation so that you're able to figure out, do I need to go with this size? Or I need to go with that size? It looks like I have a few more questions that just popped up. So the UL listings, are they the same or different wall assemblies UL numbers? They are all going to be different depending on what I'm kind of confused on what you're asking here. So with your studs, you're not really adding to UL. I mean, you're typically going to be doing that with your fire assemblies. Every single one's going to be different. Every assembly is going to be different. But the goal is to obviously hit that 1 to 2 hour minimum. I can elaborate a little bit more on that. I'll write that question down and get it back to you. What are the differentiates between each manufacturer since the quality is determined standard? So it really just depends. A lot of cold form steel manufacturers for studs, typically your commodity studs, there's not really much of a difference. They're all going to be using pretty much the same galvanization. They're still going to be using the same type of steel. It's going to be the same millage, the same heights. Maybe they have height differences. But for the most part, you're not seeing a ton of differences. That really comes down to realistically price when you're putting it on a project. I think what makes steel stud manufacturers stand out is really their specialty items and other ways that they're, maybe they have something that another manufacturer doesn't offer. But as far as like regular typical cold form partition steel, it's all pretty similar. They might have different cutouts. They might not have the dimpling, but essentially they all kind of work the same. Okay, we have an anonymous attendee. They say these are referred to as cold form steel. Are there hot form steel studs? I have never heard of a hot form steel stud. Cold form steel is basically the way that it's manufactured. I will double check on that though. Like I said, I am just 8 months into cold form steel manufacturing, but I don't believe that there is a hot form steel. Where are coiled rolls manufactured? In the US or somewhere else? So they can actually be manufactured. There are some, most of them are domestic, but there are some that we are getting from out of the country. So these coils are being manufactured all over the place. Obviously the goal, I know a lot of architects would like them to be done in America, and there are a lot of cold form steel producers that are in America. Okay, Scott Mushev, I'm sorry if I pronounced that wrong. If the coils are galvanized prior to stud manufacturing, wouldn't all studs have a raw cut made in manufacturing as the studs are not galvanized after they are formed? That is a great question. I'm so sorry, guys. These are questions I'm definitely going to have to ask the manufacturing facility. This is not something I've been taught before, so I will definitely take note of this and get back to you, Scott. I appreciate it. Gumilos, oh my goodness, I am so sorry if I did mispronounce this. Guillermo, is there any additional coatings for the studs to protect from moisture? For an example, saunas. So no, so typically steel is only going to be in that zinc as well as the other EQ equivalents. So you have those or just anything else that is considered an equivalent, but they have to be approved by code. I don't think that there's anything that you add extra for something like a sauna. That's more so something where you're going to rely on your exterior waterproofing applications and basically your building envelope, just trying to avoid moisture at all costs getting to that stud. It's kind of like when you think of a rebar. You don't want any moisture getting to that rebar because then you deal with corrosion and then you look at all types of failures, building collapse. It's kind of the same thing. We're just kind of putting a film on that as an extra coating protection. Stephanie, what are the main differences between load bearing and non-load bearing cold roll studs? That is a great question. So load bearing is going to be a structural component where non-load bearing is not. So when you're looking as an example, let's use a apartment complex. When you're looking at an apartment complex and you've got 2 units on each side, yes, you can have your fire rated walls that are typically going to be separating the different units, but your partitions that are just separating, your bedroom from your living room or like your bathroom from your bedroom, those would be just a partition non-load bearing wall. That is strictly just to put a separation from room to room. When you have a load bearing wall, such as like your shear walls that are going to be on the exterior of the building, or something that is going to be contributing to the structural component of the building, basically the skeleton that's holding up the building, that's the main difference. Stephanie, another question. Where are the factories located that make steel studs and other shapes? Do you know the locations in Florida? So I do know that there are some people, not with my company, but there's companies that are actually located in Florida. I'm unsure if they're manufacturing. Well, actually, no, there are manufacturers in Florida. I believe some of them are in South Florida. There are also some that are all over the United States. I know that there's some in Chicago, there's some in New Jersey, there's some in California. So you can actually find these steel manufacturers all over the United States. Okay, were there any other questions? I'm going to check the chat one more time. Have you had any price issues due to the tariffs? Where does your steel come from? So I'm gonna, because we are still in the AIA, I won't speak specifically on my company. I will say that every single steel manufacturer has dealt with price increases because of tariffs. That's not really necessarily because of tariffs. I think that the steel manufacturers over time, we were actually due for an increase throughout all manufacturers. And it really just depends where they're getting their steel. If they're getting it domestically, I don't know that they were affected as much because we're not dealing with those overseas tariffs. So it really just depends where your steel is coming from. And like I said, if you have any questions specifically on my company, you guys can reach out to me. But as of right now, we're keeping it kind of generic right now. Let's see. There was another question in here. 1 second. No, it looks like that's all of them. Let me just check the Q&A one more time. Is there any more questions anybody needed? Okay, we'll check this chat one more time. Okay, well, we have just a few more minutes. If there's any more questions, please type them in the Q&A. Otherwise, I want to thank you guys for joining me for this presentation. This is a very intro presentation to steel, basically just kind of going over, what it is, what it incorporates, how it's used. If you have any questions, by all means, remember to please take my email down. I will actually go down to that slide one last time. That way you guys have it. And then you can actually email me, and anything I was not able to answer, I will get that back to you. Oh, looks like it popped off. Like my presentation just doesn't want to work with me today, does it? Let's get back to that slide. So once again, here's my email as well as my phone number. If you guys have any questions, you guys can reach out to me. I can answer anything I wasn't able to answer today. I will be sure to get with Crystal to follow up with all the questions that I need to follow up on. And with that being said, I just want to thank you again for joining me, and I hope you guys have a fantastic day.
Thanks, Taylor. there did a question did appear. Are
Okay.
steel studs cost effective compared to wood studs?
So steel is going to be more expensive. Steel is more expensive, so it really just depends where you're installing it and what your uses of it are. But there's a lot of benefits to using stud as well. So it really just kind of depends, you're having to go back and fix something on a project, what type of protection you need. That's what it really comes down to. But I would be fibbing if I said that steel is cheaper than wood. Now I do know that there was a lot of wood increases. So I would like to double check on that because I know that, kind of like how we had tariffs on steel, we were also having, some issues during the COVID times with wood. So I don't know if maybe that's made a difference. So that's something I would keep in mind. Anybody else?